Today, we're diving into a super clever invention that uses some pretty basic physics to solve a dusty, chalky problem that, let's be honest, we've probably all dealt with. So let's see how a little static electricity can make our classrooms a whole lot cleaner.
You know exactly what I'm talking about, right? That dry, kind of gritty feeling. It's such a universal classroom experience. But it turns out that chalk dust is actually way more than just a nostalgic memory. And that's where we're going to start. We're going to explore why this seemingly small annoyance is actually a pretty big and persistent issue that affects, well, everyone in the room. See, the real issue is that we're talking about ultrafine particles. They're so tiny and light that they just hang out in the air, floating. They're too small for simple filters to catch, and they basically ignore gravity. So they don't just settle on a desk. They stay up there, waiting for you to breathe them in. And this invisible cloud, it has some very real consequences. For starters, it can trigger allergies and asthma for both students and teachers. It also creates this constant layer of grime on every single surface. It even gets inside sensitive electronics, like projectors and computers, causing them to overheat and fail. It's this never-ending problem that no amount of cleaning ever seems to solve. And here's the kicker. The very act of cleaning can actually make the whole problem worse. When you take a dry eraser to a blackboard, you're not really getting rid of that fine dust. You're basically just launching it right back into the air to be inhaled all over again. But what if you could just pull that dust right out of the air? Well, that brings us to the solution, a really elegant device designed to do exactly that. So, meet the static charged water-based chalk dust collector. Okay, I know that's a mouthful, but the idea behind it is incredibly simple. It basically harnesses two really common things, static electricity and water, to trap that pesky dust for good. Here is the key difference, right? This isn't just a passive filter that sits there waiting for dust to drift into it. No, it actively pulls those tiny particles out of the air using a force of nature that we're all very familiar with. So, how in the world does it actually work? Well, the answer isn't some kind of high-tech magic. It's just really, really clever physics. The science that makes this all possible is called the triboelectric effect. And if that sounds intimidating, don't worry. You already know exactly what this is. It's the static electricity you make when you rub a balloon on your hair and it sticks to the wall. It's that simple. Charge through friction. Okay, so here's how the device puts that principle to work in 3 easy steps. First, a fan sucks the chalky air into a tube. As the dust particles rub against the inside, they pick up a static charge. Boom. Second, that freshly charged dust is now irresistibly pulled by an electrostatic force straight into a container of water. And third, the moment that dust hits the water, it's trapped for good. The only thing that comes out the other side is clean air. And here's the payoff, side by side. On the left, you've got the old way. Wiping just throws dust everywhere. But on the right, you have this new solution. The dust is actively captured and permanently removed from the room. No re-release, no second chances, it's gone. So, what does this all mean for the actual people inside the classroom? Well, this is where the invention's impact really starts to shine, creating this amazing ripple effect of positive changes. And what's really important is that it's designed to be completely safe for a classroom environment. There are no complex, high-voltage electronics here. The whole device relies entirely on that simple, harmless static charge from friction, literally the same kind that makes a balloon stick to a wall. So who wins here? Well, pretty much everyone. Teachers and students get to breathe healthier air, with way fewer allergens floating around. At the same time, the maintenance staff's job gets a whole lot easier and more effective, because they're not fighting a losing battle against dust that just keeps coming back.
So when you add it all up, the overall impact is just huge. You're dramatically reducing allergens, you're protecting expensive electronics, and you're creating a healthier, more hygienic space. Ultimately, it makes sure that what's circulating back into the room is clean, breathable air, which is exactly what every learning environment should have.
And this kind of leaves us with a fascinating thought, right? This device takes a really basic principle of physics and applies it to a common problem with such an elegant result. It really makes you wonder, what other persistent, everyday problems are just sitting there, waiting for a simple, clever solution just like this one?